In this video, we're going to talk about what an inverse function is. Inverse functions are related to composition of functions. Two functions are inverses if f of g of x equals x and g of f of x equals x. So the way that you want to think about inverses is that the two functions kind of cancel each other out. So they're both acting on the variable x, but they have the opposite effect, so that when I apply both functions, they cancel each other out and all that I have left is x. The notation that we use for the inverse of a function is that we denote the inverse of a function by f, and then we use a -1 sort of as the exponent. So when you see that symbol, and you'll see this in the homework, that just means that that's the inverse of the function. And we'll see that a little bit later on. Not all functions have inverses, and not all functions have inverses that are functions. A function that has an inverse function is called a one-to-one function. So if we say that a function is one-to-one, that means it has an inverse function. So we're going to start by looking at example 2. It says, show that each function is the inverse of the other. We have f of x equals 5 times x, and g of x equals x divided by 5. So you can kind of see already how these are opposites. If I multiply something by 5, and if I divide something by 5, then those two are opposite operations. But we're going to show this using this process here of finding the composition of functions. So what I'm going to do first is find f of g of x, which means that I'm going to plug g into f. So f is 5x, so I'm going to replace that x with x divided by 5. Now from here, it's just a little bit of simplifying. If I'm multiplying these two things together, I can put this over 1 if I want to be really detailed about it. 5 times x is 5, 1 times 5 in the denominator is 5. So I get 5x over 5, and then of course the 5's are going to cancel out, and I'm just going to be left with x. So it worked for f of g of x. Now I need to try g of f of x. So now I'm going to plug f into g. So f is 5x, so I'm going to replace the x in x divided by 5 with 5x. It's going to be 5x. On the top of the fraction, I have 5 in the denominator. I don't really need the parentheses in this case, so I have 5x over 5. Again, the 5's cancel, and everything simplifies down to x. So because I've got x for both of these, that means that the functions are inverses. So next you should take a look at checkpoint problem number 2. It's pretty similar, it just uses the number 7 instead of 5. But you can do this in your notes, check your answer, and then move on with the rest of the video. Next we're going to look at example 3. It's the same type of problem. We're showing that each function is the inverse of the other, but now we have functions that are slightly more complicated. So again, we're going to do f of g of x first. So I'm going to plug g into f. F is 3x plus 2. Replace that x with whatever g is, which is x minus 2 over 3. and then I have a plus 2. So for this, again, I can put this over 1 and then multiply the fractions. That's going to give me 3 times x minus 2. 1 times 3 is 3 in the denominator, and then I have a plus 2. Now, instead of distributing here, what I'm going to notice is that these 3's can just cancel out. So I'm just going to have x minus 2 plus 2, and x minus 2 plus 2, that just equals x. So I got everything simplified down to just x. Now I'm going to repeat, but do it the other way around, so g of f of x. So now I'm going to plug f into g, so g is x minus 2 over 3. Replace that x with 3x plus 2. So replace x with f, and then that's over 3. Now what I have here is 3x plus 2 minus 2 over 3. And 3x plus 2 minus 2, those cancel out, so that's just 3x. So 3x over 3, and then the 3's cancel out, so that's just x. So because I got x for both of those, that means that the functions are inverses. Now, what they didn't include in the book is an example of when you do this process and they're not inverses. So I'm going to show you this with one of the homework problems. And then you can go back and do checkpoint problem number 3. But this is homework problem number 20. It says to find f of g of x and g of f of x and determine whether each pair of functions f and g are inverses of each other. So looking at these, you notice that they kind of have the same numbers. It looks pretty similar to example 3. So you might be tempted to just say, oh, well, they are inverses, and just type in that they're both f of g of x and g of f of x are both equal to x, but that's not really the case, and we're going to see that here in just a second. So we're going to start by calculating f of g of x. For this problem in the homework, you do have to type in what f of g of x and g of f of x are. It doesn't just ask you whether they're inverses or not. So this means that I'm plugging g into f. So f is 3x minus 7. Replace that x with x plus 3 over 7. Now, what I can see is that in this one, I do not have the same number here that's going to cancel with this fraction. So when I do this multiplying step, that's going to give me 3x times x plus 3 on the top, and 1 times 7 is 7 on the bottom, and I can't just cross off these two numbers. So what I need to do here is distribute the 3. So that's going to be 3x plus 9 over 7. Now, what MyMathLab is going to want you to do here is get this as simplified as possible, which means you actually need to do the subtraction. In order to do the subtraction, you need to subtract these fractions, and in order to do that, you need a common denominator. So I need to put 7 over 1, and I need to multiply the top and bottom here by 7 to get a common denominator. So this is 3x plus 9 over 7. Keep that for right now. And then minus 7 times 7 is 49 over 7. Now when I'm subtracting fractions, even though these are slightly more complicated than our regular old fractions, but the same idea, I'm going to subtract what's on the top, and then my denominator is going to be 7. So it's going to be 3x plus 9 minus 49 all over 7. Denominator stays the same. And then lastly, I'm going to combine plus 9 minus 49 is minus 40. over 7. From here, there's nothing else I can do to simplify. So in this case, it did not get all the way down to x. So this is telling me I don't even need to calculate the other one to see that they're not going to be inverse functions because this does not equal x. However, for the homework, you will need to calculate the other one because you're going to need to enter all parts of the answer to get full credit. Fortunately, the other calculation is a little bit easier. So this is the answer for f of g of x. So for g of f of x, now I'm going to be plugging f into g. So go all the way back up here. F is 3x minus 7. So I'm going to replace the x in g with 3x minus 7. That's going to be 3x minus 7. And then g is x plus 3. So that'll be plus 3 over 7. So like I said, the simplifying on this one is a lot easier. All I'm going to do is combine those numbers on the top. And there's not much else that I can do with this. So that'll be 3x minus 4 divided by 7. Nothing I can factor out or cancel or anything from that. So that's g of f of x. So are these inverse functions? No, they are not. So you can look at checkpoint problem number 3 in the book. Do this in your notes, and then check your answer with the notes that are posted, and then move on to the homework for this section.